Principle of superposition of waves. In this, principle of superposition of waves means when two or more waves traveling in a medium along the same direction or in the opposite direction, if they superimpose on each other, then the resultant displacement is the algebraic sum of the displacement. This is called principle of superposition of waves. When two or more waves traveling in a medium along the same direction or in the opposite direction, then they superimpose on each other, then the resultant displacement is the algebraic sum of the displacement. Now here I am taking a wave, that is a y is equal to y of x comma t is equal to a sin kx minus omega t. I am taking, this is a equation 1 I am taking, and one more wave I am taking, this is y1, this is y2 of x comma t is equal to a sin kx minus omega t plus 5 I am taking. Here these are the two waves traveling in a medium, then they superimpose on each other, then the resultant displacement y is equal to the algebraic sum of the displacement y1 plus y2. Here then by equation, by a formula, we have already sin a minus b plus sin a plus b is equal to 2 sin a plus b by 2 sin a plus b by 2 by sin a minus b by 2, that is will get, that means here y is equal to a sin kx minus omega t plus a sin kx minus omega t plus 5. This we can write a as common, then we'll get 2a sin kx minus omega t plus kx minus omega t plus 5 by 2 will get, that is will get into cos 5 by 2, cos 5 by 2. This is by this we can write 2a cos 5 by 2 into sin kx minus omega t plus 5 by 2. This is the resultant displacement 2a cos 5 by 2 into sin kx minus omega t plus 5 by 2, where this 2a cos 5 by 2 is the amplitude. This 2a cos 5 by 2 is the amplitude of the equation. Here this a of 5 is equal to, that is the amplitude, 2a cos 5 by 2, this is the amplitude. Here when these two waves are traveling in the medium, then here always the amplitude is changing from point to point. The amplitude is changing from point to point. Here when these two waves are traveling in the medium, that is in the opposite direction, then the displacement, the resultant displacement will get a 0. This resultant displacement will get 0. This is called when the displacement is 0, then we call it as a destructive interference. Here we'll get, in the case of this one, that means superposition of waves, will get a interference, that is two types of interferences we have, that is a constructive interference and a destructive interference. Here in this destructive interference, where the displacement, resultant displacement is 0, is called destructive interference, and the resultant displacement is maximum. If the resultant displacement is maximum, then it is called a constructive interference. Here the resultant displacement is maximum when phi is equal to pi phase angle. If the pi is equal to phi phase angle, we'll get a maximum displacement. That maximum displacement is called a constructive interference. Here, now this is the principle of superposition of waves. When two or more waves are traveling in a medium, then the resultant displacement is the algebraic sum of the displacements. Now, reflection of waves. In this reflection of waves, here in the reflection of waves, this is same like our regular reflection. Then here I am taking a end. For this rope or string is tied with the support. Then for this support a string is I am taking, and when the disturbance caused in this string, then this is traveling along this direction. The pulse is traveling along this direction. Here this pulse is traveling along this direction, and after reaching this end, again the pulse again comes in the same direction. That means after reaching this pulse again comes along this direction. Here in this, the pulse is traveling along this direction. After reaching the end, this pulse is traveling in the opposite direction. This is called a reflected wave. When a wave is traveling in a medium, then sometimes the wave again reflects from the other end, reflects to the other end. Then here, when a wave is traveling in a medium, if it reaches the other end, then some part of the wave is transmitting. If the some part of the wave is transmitting, then it is called a refracted wave. If some part of the wave is transmitted, then it is called a refracted wave. For this refracted waves, then it follows the laws, that is Snell's law of refraction. It follows the Snell's law of refraction. And when a wave is not transmitting and again it is reflecting back, in this case as usual the reflection laws are valid. In this reflection of waves, the wave is traveling again, after reaching the end again it comes back in the same direction in the opposite. That is reflected wave. In this reflected wave, the reflection laws are valid, and when some part of the wave is transmitted through the wave, then the refracted wave, this is called refracted wave, and this follows the Snell's law of refraction. For example, if we take the displacement relation for this y is equal to a sine kx minus omega t plus phi. Y is equal to a sine omega kx minus omega t, and for that okay, this is the wave. For that a sine kx minus omega t plus phi. This is the reflected, this is the wave. For this, the phi is equal to 0. Okay, here this phi is equal to 0. Then we'll get a reflected wave. Then by this we can write this is the wave and this is the reflected wave. Then this wave and reflected wave, okay, here the superposition of these two waves gives the zero displacement. Then the total displacement y is equal to this y1 plus yr, then a sine kx minus omega, this we will get a zero displacement directly. When the phi is 0, when the phase angle is 0, then we'll get a zero displacement.